Okay, let's actually go through a question then where we're using our divisibility tests. So we're going to put together what we done just now and a bit from the previous video. So we've got quite a big number here, 21,549, and we need to show divisibility by 33. Now, 33 was not in that table. Okay, so the first thing I'm going to want to do is rewrite 33 as a product. Now, what I must ensure in this product is that the numbers in there are co-prime, that they have a highest common factor of 1, because then what I can do is show the divisibility of each of the factors individually and then come to the conclusion that 33 must be a factor. So one way, if you're unsure what factor pair to pick, you could just find the prime factor decomposition of the number as a start point. You don't have to do that. Now in this case, you could use 3 times 11, which is the prime factorization. Okay, so what I'm going to do is I'm now going to do a divisibility check for both 3 and 11. So let's do 3 first. So we're going to add up the digits of 21,549. Okay, so 3, 8, 12, 21. Now 21 is a multiple of 3. It's equal to 3 times 7. So I can say, therefore, 3 is a factor of 21. Therefore, 3 must be a factor of the initial number we started with. Like that. Okay. Then what I'm going to do next is we're now going to do 11. So for this one, remember, we'd start with positive 2. Then we're going to subtract the next digit, which is the 1. Okay, then we're going to add the 5. Then we're going to subtract the next digit, which is 4. And then we're going to add the 9. Okay, so 2 subtract 1 is 1, plus 5 is 6. Take 4 is 2, plus 9 is 11. Okay, so therefore, well, 11 is a factor of 11. Just make sure your line in the middle is bigger than the numbers, because you don't want to mix it up with the ones. So therefore, 11 must be a factor of the initial number that we started with. So now what we need to do next is we need to write a conclusion, okay, because we're not finished yet. What we need to say is, since 3 and 11 are factors of 21,549, and the highest common factor of 3 and 11 is equal to 1, we can say that 3 multiplied by 11, which equals to 33, must be a factor of 21,549. Okay, so that's the type of conclusion I'd expect. So we're now going to look, well, we're not going to do a full question. We're just going to look at how potentially we'd figure things out for example, 60. Okay, 60 is quite a big number we've got going on there. Now, if you try and think of factor pairs of 60, you'll likely not get a pair that would necessarily have the divisibility checks you're familiar with. Well, what you can do, you can write it as a product of 3 numbers. So, for example, some of the numbers that we've made use of previously that might work would be 3 multiplied by 4 multiplied by 5. Okay, because you've got 3 times 20, which is 60. Okay, and then what you'd need to do is do the individual divisibility checks for 3, for 4, and for 5. Okay, and the reason why, once we've established their factors, we'd be able to multiply them together is because 3, 4, and 5 are what we call pairwise co-prime. So what that means is if you take any pair of those 3 numbers, so for example 3 and 4, the highest common factor of 3 and 4 is 1. If we took a different pair, the highest common factor of 3 and 5 is 1. If we took a different pair, the highest common factor of 4 and 5 is 1. Okay, and as long as that's the case, you can multiply the three numbers together and assume that the result is a factor. So you'd have to mention pairwise coprime in your conclusion if you were doing 60.